A very warm good morning to all our viewers. Welcome to the second session of DSC ML Talks. I'm Aman Sharma, the ML lead at DSC VIT Bhopal, and we have among here I'm Aman Sharma, the ML lead at DSC VIT Bhopal, and we have here among us the entire DSC ML team: Ayush Mishra, Indrashish Paul, and Yash Sinha. As you know, the DSC ML Talks is going to be a month-long event where we'll be organizing hands-on machine learning workshops and speaker sessions with some industry experts. This session is a hands-on workshop where we'll be covering topics like Introduction to Google Colab and hands-on workshop sessions on NumPy and Pandas, two of the most important PyData packages available in Python. So without any further ado, let's kick off our event. Ayush will now give you a demonstration on how to use Google Colab.
All right. So hello everyone, and without wasting time, let me just quickly share my screen so that you can see the window. Avan, can you please confirm if you can see my window?
Yeah, it's visible.
All right. So hello guys. This is your introduction to Google Colab. Make sure you understand everything very well because this is what we'll be using for all throughout this live stream. And further, when we at the end of the live stream, we have some tasks for you. So for that as well, you'll be using Google Colab. So make sure you go through all of this very well. Now, once you go to collab.research.google.com, you will be greeted with this page first. It basically tells you what is collaboratory and how different things are. It will just give you a basic walkthrough of everything that Google Colab has to offer. Now, let's start off by quickly importing a notebook. Now I'll show you how it is done. So you can just go to Files and you can open Notebook. Now you have all these options with you. So you can open the recent notebooks that you had. You can open your notebook from your Google Drive. You can even upload your notebook. And for this one, we'll be using the GitHub to upload our notebook. So I'll just go, and this is our repo of DSC VIT Bhopal. It is the DSC ML Talk resources. So this is where you'll find all the resources from even from the session one and as well as from today's session that we have. So everything that you need will be in this repo. So make sure you start it, and I'll just copy this link and paste it over here. And when I do this, as you can see, I have all the notebooks that I have. So it will contain all the .ipynb and .py format notebooks for me. So introduction to Colab is what we'll be using for this one. So once we have our notebook, I'll just connect this over here. And this is how a complete notebook would look like. You won't necessarily get this theme maybe when you open up Google Colab, but you can obviously go and change it in the settings. Now I'll just give you a demo of some of the tabs that we have over here. So this is just the table of contents that you have. These are the headings for the content that we have in our notebook right here. This section contains the code snippets for you. So there are some pre-built or pre-made codes present in Colab for you to access. So this is where you can go and access them. This is just search and replace. So you can just search for a word and replace it with a word. And this is the section that you will be using. So this is where you can import your data or some other notebook that you want. So I'll just right click over here and upload. And I can just go and import this data set, which is Titanic, which is what we'll be using in when we are doing Pandas, which is later on in the stream. And yeah, so once you close this notebook and your runtime is recycled, this data set won't be available. So you need to get it once again, like you need to import it once again. So this is how you basically import your data set. And I'll just give you a basic walkthrough of Colab. So these boxes right here are the text boxes or text cells that you want, that you know, these are basically markdown cells that you have. So shift and enter will run a cell for you, or you can just, this is a text cell. So as you can see, you will get this. So you will just run that over here, and this is your code cell. So you can write your code in this cell and just print it for you. So I'll just write one small code for you. Okay. And when I run it, you will find that we have these printed. So these are the code cells. Now there is something that Google Colab has to offer, that is CPUs, GPUs, and TPUs. So CPUs are designed to solve your basic computational problems that you have. CPUs are good enough to solve them, the basic programming that you do. CPU can handle them. Even they can handle some of the machine learning, small scale machine learning projects. Then GPUs were designed. These are the processors which were designed to accelerate the rendering of your graphics. They are also used for machine learning and deep learning, so that they can train your model faster. Now, TPU is a co-processor, which means it is built to support the processor in one sense, and it was specifically designed by Google for TensorFlow, which is also provided by Google. So, yeah. You can think of TPU as basically as an accelerator, and uh, yeah, that's pretty much it. And most people say that TPU is nothing but NVIDIA's GPU on cloud. So that's one thing. So I'll show you how you can initialize your GPU over here. So just go to File. When you go to File, you have these other options as well, which I would like to show you. This is an option for creating new notebook, opening a notebook. You can save these copies on GitHub, download the IPyNB or .py version, edit. You can just explore all of these once you are in Colab. So I'll just go and go to the files, or maybe you can just go to runtime and change runtime type. Now from here I can select my hardware accelerator. For this one I need a GPU, so I'll go and save this. So once we are good to go over here, I'll run these code cells for you, and I'll show you how it works. So now we are connected, and when I run this, hopefully we get GPU found as an output. It will take some time to run, and yes, we have the GPU has been loaded. And this is just a code snippet, small code snippet that TensorFlow provided us, and that I would like to show you, which compares the time taken by GPUs and CPUs. So it's a good comparison between the speed of how GPU is faster than CPUs. So as you can see, GPU speed up over CPU is 81x. So all of this code that you see here will be provided you in the GitHub repo. So make sure you check it out. And similarly, in such a way, we can also initialize our TPU. The same way we can change runtime. We can go over here, instead of GPU, we'll use TPU. I personally haven't worked with TPU much, so I was not okay with adding much code to this to compare it. But yeah, you can obviously use TPU if and when you need it. I'll just run this cell. And as you can see, running on TPU, and once it is all executed, you will have your TPU working for Colab. And yep, you have your TPU initialized, and this is how basically the whole thing works. So this was it for the whole introduction session for Google Colab. So what we did was we went through the whole, just walked through whole Colab, how things are, how you can import your data, how you can get things into Colab, how to import notebook from GitHub, from Google Drive, and stuff like that. We also saw what are text cells and what are code cells, and we saw what CPU, GPU, and TPUs are and how to use them. So yeah, I would like Yash to continue with the next session, which is on hands-on NumPy. Make sure you pay good attention to it, and yeah, that will be it from my side for now.
So hello everyone, I will be introducing you all to NumPy. So NumPy is a Python library used for mathematical functions in the domain of linear algebra or Fourier transformation. So why we use NumPy? In Python, we have lists that serve the purpose of arrays, but they are slow to process. So NumPy arrays are 50 times faster than the traditional Python lists because they are stored at a continuous location in the memory. So the array object in NumPy is called ND-array, which provides a lot of supporting mathematical functions, which make working with ND-array very easy. And arrays are very frequently used in data science, where speed and resources are very important. So how to install NumPy? So if you have already installed Python in your laptop, all you need to do is to go on command prompt in your PC and write pip install NumPy, and NumPy will be installed. In case you are using Anaconda, you need to go to the Anaconda prompt and then write conda install NumPy. So thank you. And now Aman will give you all a hands-on workshop on NumPy.
Hey everyone, can you confirm if my audio is? Can you hear me?
Yeah, I can hear you.
All right.
And your
So
screen is
now
visible.
we'll be doing a quick session, a hands-on session on NumPy. So first of all, what I need you to do is I've shared a link in the chat. It is a link for the GitHub repo. So copy the link, then open Google Colab and go to this tab which says GitHub. Then here, paste the link. Once you have pasted the link, click on the search button and all the notebooks that are available in the repo will be visible to you. Once you're on this stage, click on the hands-on NumPy notebook and just wait for a second and the notebook will open. Okay, so welcome one and all to the second session of DSC ML Talks event. And in this hands-on workshop, we'll be working with NumPy, which is one of the most important PyData modules available in Python. And in this notebook, you will come across many exercises as well. So what I want you to do is after this session is over, you need to finish all those exercises and submit the notebooks in a Google form at the end of this session. And we'll be selecting some lucky winners who will be getting some DSC swags. So first of all, the most important step when you want to use NumPy in your projects, you have to first import it within your Python projects. So for this, we'll just do a very simple command, that is import NumPy as NP. Now we can import NumPy as just NumPy2, but when we'll be using the NumPy function a lot, we need to abbreviate it so that we don't write same things again and again. So here we are importing it as NP. We have to wait for a few seconds to get the notebook initialized. Alright, so now we have imported NumPy in our project. Now let us take a look at lists and arrays. So arrays in NumPy are one of the most distinguished features of NumPy module. And you can think of arrays as a substitute for the lists that are available in Python. However, the main difference between lists and NumPy arrays is that NumPy arrays are much faster. Sometimes you can see speed difference of up to 100%. So in mathematical terminology, we can say that a one-dimensional array represents a vector and a two-dimensional array represents a matrix. First of all, we are going to create a list X. As you can see, here's the list. Basically, values ranging, integer values ranging between 0 to 10. Now, what we are going to do is we will be creating a NumPy array from the list that we just declared. So for this, we just write a simple code, np.array, and within the brackets, we pass the list as an argument. So upon running, we get this array. Now, like I said before, in this notebook, you'll be coming across many exercises, and you can try those exercises on your own and get a gist of how things will be working. And once the session is over, you need to submit these notebooks by midnight today. Now, one very important thing to note is that lists and NumPy arrays are different, because in case of lists, you can have values of any data types. For example, in the single list, you can have integer values as well, floats, strings, characters, anything. However, in case of NumPy, the array can only contain elements of a single data type. That is, For example, a NumPy array can either only contain integer values or floating point values or strings, so on and so forth. So in case like the data types does not match, for example, in this case where we have some integer values as well as this is a floating point value. So when we try to create such an array, what is going to happen is NumPy will automatically upgrade this value and promote it into all the integer values into floating point values. So let us run this code cell and see what happens. Like I said before, all the integer values have been upgraded to floating point values. Now here are some more methods in NumPy that might come handy. So the first one is np.zeros, that is used for creating arrays of zeros where the length is equal to the length of the array that we want. And dtype is basically the data type of the elements in the array. You can also pass in the dimension of the array that you want to have. Similarly, in case of np.ones, we can create arrays comprising of only one values, that is one as the value. Then we have np.arrange. So this helps in creating array of elements starting from the start and going to the end while taking all the specified steps in between. So here the start is the starting integer value or the range value that you want, and the end is the final end value that you want, and step basically defines the step size that you are going to take after each number. For example, if you define step size as 2, so it will skip one element after every jump. Then we have linspace, and linspace is used for creating arrays of evenly spaced elements. We have random.randint as well. So what it does is it creates an array of the dimensions that we provide, and the elements in this array are going to be random numbers between the values that we specify for the start and end parameters. So let's see what happens when we run this code cell. So we are getting an array of zeros, and there are total 5 zeros, and the data type will be integer. In this case, we will be getting a 3 cross 4 matrix, and the values will be all ones. Now here, what we did was we used the arrange function. So what it basically tells us is that we'll be getting values between 0 to 5, starting from 0 and all the way up to 5. And the step size was defined too. So the first value was 0, then a value was skipped, like I said before. Then we got 2, then finally we got 4. And since the higher bound is 5, so we get values only up to 4. Then we have linspace. So here what linspace is doing is it is dividing the values between the range between 0 to 10 into 5 equal parts. So first of all, we are getting 0, then we are getting 2.5, then 5, 7.5, and 10. Then we have np.random.randint. So this is an interesting one. First of all, we defined a range between which we want our random integers to appear from. Then we defined the shape of the array that we want. So finally, the array that we are getting is a 3 cross 3 array where the values are random integers drawn from the sample between 0 to 20. Now, here are some exercises that you can perform later on. Now let us move on to one of the most important topics in NumPy that you will be using a lot, that is the random module. So the first thing that we come across random module is the random function. So The random functions basically returns an array containing values or samples from a standard normal distribution. So all we need to do is specify a shape parameter, that is the shape of the matrix that we want, and we'll be getting some values within the array that are drawn from the standard normal distribution. So let us run the cell. Here we are creating an array with random values from the normal distribution, and the shape is 3, 4. That is 3 cross 4. So this is the array that we got upon running the cell. Once again, some more exercises for you. Now what we are going to do is we are going to define 2 more matrices. So if you notice here, we have used the random function from the random package in NumPy, and here we have specified the lower bound as 0 and the upper bound as 100, and then we want a 4 cross 5 matrix out of it, and the values will be drawn from this range 0 to 100. The next we have another array that is created using the rand function in the random package, and it is going to be a vector basically of size 10. So let us see what we get upon running this cell. So as we can see, we have got array x1 that is of the shape 4, 5, and these are all integer values. Then we have the array x2, which is all floating point values, and the size is 10. So now we are going to look at some of the attributes in NumPy, that is ndim, shape, size, and dtype. So what ndim does is it gives us the number of dimensions within our array. So in case of x2, if we see here, x2 has just a single dimension. That is since it's a vector. In case of shape, let us run the cell once. Yeah, so yeah, in case of the dimensions, x2 has just a single dimension, and in case of shape, x2 shape is 10, and then just a second, small mistake here. Okay, so in case of size of the matrix, the value that we get is the total number of elements within the matrix. So if we look at the array x1, here we have a 4 cross 5 matrix, and so the total number of elements will be 20. So this we are getting the same thing using the size attribute. So these were a few attributes that we come across a lot in NumPy. Now we'll be taking a look at another important function in NumPy, that is indexing. So in case of NumPy, just like vanilla Python, the indexing starts from 0. So if we want an element at the 0th position, what we are trying to access is the first element in the array. So let's run this code cell. Here we are trying to access the 0th indexed value within the array x2, which is 0.3609. As we can see here, the first element is this one. Then next we are trying to get the value that is indexed 1. So we can get it like this. Now if we look at the array x1, here suppose we want the first value. So here we have to first specify the row number, and that is the row index, and then the column index. So in order to get this value, the row index will be 0 and the column index will also be 0. So here we can see we specified x100 and we got the value 83. Similarly, in order to get say this value 37, here the row index is 0, 1 and then 2. So this will be 2. And again the column index will be 0, 1 and 2. So it will be 2, comma 2. So here we specified the index values that we want as 2, comma 2. And finally we get the value 37. Let us take another example. Say we want the value 57. So here the row will be 0, 1. So row will be 1. Let me just change this one only. And the column value will be 0, 1, 2, 3, 4. So the column index is 4. Upon running, we get the value 57 that we wanted. So this is how indexing works in case of NumPy. Now let us assume that we want to print the last element of the array. However, the catch here is that we don't know what the length of the array is. So in case of NumPy arrays, just like we see in Python list, indexing from the end starts from the value -1. That is, if we want to print the last element of the NumPy array, we can simply specify the index value as -1. Or say if you want to print the second last value, second last element of the array, we can specify the index as -2. So let us see with the help of an example. Here we are like indexing the last element of the x2 array. So as you can see, we got the last element that is 0.34. So again, an exercise for you. Now we can use these indices to even change the values of the elements in our array. For example, we will now change the first element in row 1 of the array x1 to over 9000. So let us see how this is going to work. Earlier array x1 was like this, that is all integer values that were smaller than 100. Now we are changing the first the row 0 and column 0 in element to 9001. Upon running this cell, as you can see, the value got modified. So again, one exercise for you. Then we move on to another NumPy topic, that is slicing. So how we can slice the array, basically how we can get a part of the array that we want instead of the entire array. So here, what this particular line of code will do is, it will give us the first 5 elements within our array. So starting from index 0 all the way up to index 5, and index 5 will not be included within our final result. Let us run the cell. As you can see, we got the first 5 values within our array x2. So the same thing can be written as this as well. Like we can omit the first 0 that we included earlier. If you just do a colon 5, NumPy will automatically interpret it as x2 0 to 5. So once again, we got the first 5 values. Then what this particular line of code will do is, we are specifying a colon, then again a colon, and then 2. So it will give us every other element within our array, that is the step size will be 2. Now this is an interesting one. This one will simply reverse our array. Just let me run the first one first. Yeah. This is going to reverse the entire array. So earlier we noticed that our last value was 0.34 and the first value was 0.36. But now since we have reversed the array, our first value is 0.34 and the last one is 0.36. Now we can do the same with multi-dimensional arrays as well. So in this case, the first indexes that we'll be specifying will denote the rows, and after the comma, whatever we specify will denote the number of columns. Or if you have more than 2 dimensions, then there will be some more commas basically and some more values. So here what we're trying to do is, we are specifying all the rows and only the 0th column. So it will retrieve the first column within our array x1. As you can see, these are the values. Just let me scroll up a bit, and you can verify these as well. So the first column was 9001, 19, 38, and 95. Here the values we got are 9001, 19, 38, and 95. Let us see some more examples. Here what we are doing is we want all the rows and columns up to the column index 2. So that means the first two columns within our array. I'll run the cell. Yeah, so as you can see, we got the first two columns within our array. Here, we are just doing an x2, and then we are not specifying any. X2 was a one-dimensional array, by the way. So here we are not specifying any values to the left or right of the column. So it will simply give us all the elements within our array x2. As you can see, we got all the values. And now on this one, so here we are specifying the row index as -1. That means the last row within our array, and we want all the column values. So basically what we are getting is this final row. As you can see, we got the final row. Now an exercise for you that you can try later on. We'll move on to another topic in NumPy now, that is reshape. So reshape method allows us to modify or get a mutated view of the array values and modify the shape of the NumPy array once it has been declared. So here, first of all, we declared a NumPy array, and this was the array basically. And as we can see, the shape of the array is 9. That is, we have 9 values within a one-dimensional array. Now, we'll simply reshape the array into a 3 cross 3 matrix using the reshape method in NumPy. Let me just run the cell. As you can see, the array that was earlier a one-dimensional array got reshaped into a 3 cross 3 array. Now, one thing to notice is the size of both these arrays should match. So here, if we look at the size of ARR, it is 9. And here as well, let me do a quick size. And as you can see, it is 9 as well. So if you're trying to reshape an array and the sizes don't match, you will end up getting an error. For example, let me do a 4,3 here. And since the sizes were not matching, I got a value error that says that cannot reshape array of size 9 into shape 4,3. So we defined the array first and then converted into a 2D array using reshape. This can also be done using a new access method, but reshape method works just fine, and also it is kind of self-explanatory and does not create confusion. Whenever you hear the word reshape, you will know that you are basically reshaping the array that you have already created. New access is kind of confusing. So let us now have a look at how we can concatenate two arrays. This one is fun. So first of all, we created an array, two arrays actually, array 1 and array 2, and then we concatenated these arrays. So upon concatenation, we get this result. This and this array got merged into a single array. Now you can do the same for multi-dimensional arrays as well. However, there's a quick note here. The default access for concatenation is 0. So we haven't specified an access here. So in that case, NumPy will automatically consider the access parameter as 0. And 0 tells NumPy that we have to concatenate along the row axis. So whenever you see access 0, that means we are specifying the row dimension. And whenever you hear the word access is equal to 1, that means we are specifying the column dimension. So let us have a look here at this code cell. So first we created an array 3, then we created a multidimensional array 4. And first of all, we did a concatenation along the default axis, that is axis equal to 0. Then we did a concatenation along axis 1. Here we have specified that the axis will be 1. So let us see how things work out. As you can see, things got concatenated along the row dimensions. So these are all the rows within our array. And in this case, in the second case, the concatenation happened across the column dimensions. So these are the columns, as you can see, and it got concatenated sideways. Now I can try these in the exercises as well. Let us have a look at aggregation methods in NumPy now. So aggregation methods basically treat the array as a single entity. For example, in case of minimum, maximum, or sum, we are getting the minimum value within our array or the maximum value or the sum of the entire array, that is all the values within our array. So here, first of all, we do a np.min array1, then np.max and np.sum. So this will give us the smallest element, this will give us the largest element, and this will give us the sum of the array. Let me run the code cell. So as you can see, we got all the values. Now you can do the same thing. This one was for one-dimensional arrays, and we can do the same thing for multi-dimensional arrays as well. So here we'll get all the values, as you can see. Now one interesting thing is you can specify axis as well. So upon specifying axis is equal to 0, that is along the row dimension, we are going to, just a second. Okay. I think axis does not work for this one, my bad. Then we have another exercise for you that you can solve. Next up, we have another important topic, and it is known as broadcasting in NumPy. So first of all, we created a array A and then another array B. And then we did a simple addition on those arrays. So what happened was the 0th index elements got added, then the first index elements, and then the second index elements, and we finally got this array. Now this is an interesting one. Here we are trying to add a scalar value to a NumPy array. So let us see how this one turns out to be. As you can see, the scalar value 5 got added to each and every value within our NumPy array. So this is broadcasting. Since the dimensions of these values were not matching, the smaller dimension array was like copied into 2 more dimensions, and it was created in a way to look like this actually. So it kind of got mutated into this form, and then it was added to our original array. So originally it was just like this, and we got the result as that one. I added it twice, so that's why the values got changed once again. Now here, let us take a look at these two arrays, M and A. So as you can see here, M is a 2 cross 3 array and A is just a single dimensional array comprising of 3 values. So now when we are trying to add M and A, what is simply happening is this array A, since it's a dimension shorter than our array M, it will be created into something like this. So 0, 1, 2, and then it was copied downwards as well. So 0, 1, and 2, and then it was added to a original array M. And upon addition, we get this result. So broadcasting simply means that if you are trying to add 2 arrays of different dimensions, so in that case, according to some rules, the one with the smaller dimension will be like mutated into a higher dimension array by simply copying the values in different dimensions, and then it will be added to the one with the larger dimension. Now let us see the comparison operators in NumPy. So here we are doing a is smaller than 12. So what is going to happen is all the elements in the array 1, array A are going to be compared to the value to 12 that we specified here. And if the particular value within the array is smaller than 12, we'll get the boolean true for that particular value. Otherwise, we'll get the boolean false. So as you can see, since 11 was smaller than 12, we got true. Then 12 is not smaller than 12, it is equal to 12. So we got false. Then again, for 13, we got false value. Now we are on to the final topic here, that is fancy indexing in NumPy. Let us take a look at this array X. Now in order to grab the elements at position 3, 4 and 10, we can do something like this. That is we specified index 3, then index 4 and index 10, and we wrapped it around in a simple Python list. So this is the final value that we got. Now there's another way to do this operation using fancy indexing in NumPy. So first of all, we created an array, and within that, not an array, actually a list in Python. And for that list, we specified all the indexes that we want. Then just like we did indexing earlier, we specified this entire list as index value for our array X, and finally upon running this, we'll be getting an array of all the values that we wanted earlier. So just a fancy way of indexing, you can say. Now we are creating an array of the first of all, we created a range of 25, and then we reshaped it into a 5 cross 5 array. So here's the result that we got. An array with values ranging from 0 all the way up to 25. 25 not included, hence 24. Now what we are doing is we are specifying row indexes in a NumPy array called row, that is 0, 1, 2, and then column indexes in this another array, and we are doing a fancy indexing here. So what is simply happening is we are first getting the 0, 0 indexes, so 0, 2. So y1 0, 2 is, this is 0 and 2, it will be 2. Then y1 1, 1 will be this one, 6. Then y1 2, 3 will be row 2, that is index 2, and then the column number 3, so 0, 1, 2, 3. So this is the value that we want, that is 13. So this is how fancy indexing works in case of multidimensional arrays. Again, we can use fancy indexing to manipulate the values in our arrays as well, just like we saw earlier in case of simple indexing. Now, I guess the final topic here is sorting in NumPy. So first of all, we created a simple array, that is unsorted array, and then we use the numpy.sort method on this one, and this simply sorts all the values within our NumPy arrays. Now there's another function called numpy.argsort. So in case of numpy.sort, the array simply got sorted. However, in case of argsort, we simply are getting the indexes of the value that we need to arrange in a particular order in order to sort our array. So the first index in our argsort array is 7. So in order to sort the array, first of all we have to bring the 7th index element, that is 1, to the first position, then 0, then index 1, then index 4 in the original array. Once we arrange the values in this manner, we'll get our sorted array. So in case of numpy.sort, it will simply sort the array, and in case of numpy.argsort, it will give us the indexes of the values that we have to arrange in an order from the original array in order to get a sorted array. Here we created an array. Then we can like sort the arrays along the column dimension as well and the row dimension as well. So one interesting thing here is that we are specifying for the column dimension index 0. However, I told you guys earlier that whenever we see axis is equal to 1, it is for column dimension, and whenever we see axis is equal to 0, it is for the row dimension. So why we are specifying axis 0 here for sorting elements along the column dimension. So basically what is happening here is we are collapsing the array and performing all the function, all the operations along the row dimensions in order to get a sorted array along the column dimensions. A bit confusing, I know, but once you start practicing with NumPy a bit, you'll understand how dimensions work. Finally, we got a sorted array along the row dimensions. As you can see, the values are all sorted. Finally, a simple exercise for you. And with this, we come to an end of our NumPy section. Congrats on finishing this tutorial. Now we are going to have a quick quiz now. Let me just share the link once. And keep in mind, the winners of the quiz will be getting an awesome DSC swag. So stay tuned for that one. Let me share the link in the chat once. You'll be having just 3 minutes to attempt this quiz. And once the time is up, the submissions will be closed. Again, I'm repeating, the winner gets to take away a prize. The link has been shared for the quiz. Go ahead and attempt the quiz now. Your time starts now. The time is running out. Be quick. Make sure that once you are done with the quiz, click a screenshot and share it on your Instagram tagging DSC VIT Bhopal. The responses have started to pour in. The time is running out. Be quick. Final 30 seconds on the quiz. All right, we won't be accepting any responses now. So we can move on to our next session, that is hands-on workshop on pandas.
Is it visible?
Yeah, it's visible.
Okay, so hey everyone, I'm Indrashish and let's start with pandas. So a quick introduction to pandas. It's a powerful and open source data analysis and manipulation tool built on top of NumPy. It's easy to use, fast, and flexible. The best thing about pandas is that it gives us a very easy way for us to represent data in the memory. Now, a quick background on pandas. Some believe that the name pandas was abbreviated from Pandas Data Analysis Library, while Wikipedia states that it's actually an abbreviated form of panel data, which is a multi-dimensional data structure provided by pandas. But let's not go that deeper. The thing about pandas is it is quite a game changer in regards to data analysis. Data analysis can be done very efficiently and like easily using pandas. And to be honest, it's actually the most widely used data wrangling, or in easier terms, data manipulation tool throughout the world. But the coolest thing about pandas is the primary data structure it provides. It can take any like different variety of data types, like file types, like a comma separated value file, a tab separated value file, or otherwise known as TSV file. It can also take in text file, HTML documents, and even SQL databases. So how does pandas actually use those, and how does it efficiently manage the memory using these files? So pandas has a unique data structure called data frame. It takes in all these different types of files and makes the data from these files into rows and columns. It represents them in rows and columns, and that is known as data frame. Now, data frames like pandas provides various types of functionalities on data frames, which makes it much faster and efficient than working on lists, simple lists. I'll give you an example. If you want to iterate some so from data one data to the other, and you have a large quantity of it, in case of lists you would need for loops or even list comprehensions to iterate through the from the first to the last of the data. But if you use pandas data structure called data frame, it can be done very easily with very low memory usage. That is how cool pandas is. Now, before using pandas, obviously we'll need to install it, and like I've shown, you can use your command prompt or terminal to install pandas. And if you have a distribution of Anaconda downloaded in your system, you can obviously open up the terminal from that Anaconda distribution and use conda install pandas. It will directly automatically install all the required dependencies, and it will install pandas in your system. And if you're preferring using PyPy, you can always use pip install pandas from directly from your command prompt or terminal. It will also get all the required files for pandas downloaded in your system. Now, that was it about pandas. We'll explore a huge deal on how to work with pandas, how to work with data frames, series, and also at the end of the at the like after having done few functionalities on pandas, we'll also get some hands-on with a real-world data set. So let's get started.
All right, so I'll be walking you through the pandas, or I'll be giving you the hands-on exercise, hands-on experience with pandas. So I'll just share my screen. Is it visible?
Yes.
Yeah. So okay. So thank you, Indrishi, for giving us the whole overview of what pandas is and how you can use it. So I'll just walk you through some of the basic syntaxes and some basic codes that you need to know when you're working with pandas. And so let's get just started with this. So as I told you in the introduction session, this is our text cell, and these all are text cells. Now, this is the command that you saw in the previous slide, which taught you how to install pandas. So you can use this and install pandas on your system. So once it's done over here, it will run this code snippet as we saw in the first introduction to Colab session as well. So it is just initializing the notebook over here. So as you can see, requirement already satisfied. So we officially have pandas to work with. We will just import the dependencies that we need for this notebook. Now, this is an exercise for you to do. So we will not show you how to import it. It's the cell is actually hidden. So you won't be able to see the code, but that's an exercise for you. Okay, so let's start off with Pandas series. So Pandas series, if I have to define it, it's like it's basically a one-dimensional labeled array, which is which can be used for holding any type of data in it. So the data can be int, float, string, or anything. But there is one catch that the data in this in the series should be of the same type. That, for example, in list you could include a number and a string as well. But in case of series, you can only include similar type of data types. So let's quickly go and start with the pandas. So here on this code cell right now, and these are our labels, ABC, my data, which is another list. So both of these are lists. We are using np.array to create an array using my data, which is over here. And we also have a dictionary over here. So I'll just talk you through what is happening over here when we run these slides. So we just created two lists, an array and a dictionary, and series can be created using these very easily. And I'll show you how. So in this next cell, we will be using arrays and the labels that we created. That is a list that we created in order to create our Pandas series. So I'll just run this cell for you. So this is what our series looks like over here. So we use the labels, that is ABC, and then which acted as our indices, and we are using our array, which was made up using my data, which was this 10, 20, and 30. So this is what we have. This is our series that we have, and it also all the types are integers. Then coming to dictionaries. Now, as you know, using dictionaries, you can make the series as well, and it is the easiest way to create series, because as you know, dictionaries are basically key value pairs. So for every key that is here, A, B, and C are our keys over here, and 10, 20, and 30 are the values. So what we are doing is we are just using this dictionary to create our series. And as you can see, both of these are the same things, because our labels here were ABC, which were acting as our indices. And in this case, our keys are acting as our indices, which are A, B, and C. Now, we can also, if you want, I'll show you how you can, there is something called implicit and explicit indexing. So I'll just show you one small thing. So as you can see, when you write this code, you will get this prompt. So it will tell you what all you can input in this. It also tells you what you are using here. So it is telling you one-dimensional ND array with access tables and all. It tells you about series. This is what this is how Colab helps you in your environment. So you can actually just use ARR over here, which was the array that we created using my data. And I'll just print X, so I'll be able to explain you what are okay. So as you can see, we did not give any index over here. In the above case here, we were giving labels as our index, and here we are not giving. So this is a case of explicit indexing where we are giving the indexes that we want and indices that we want, and this is a case of implicit where we are getting indices given by the pandas to us for our data values. So this is just one thing that you need to know, and I'll come back to this further when I go down in the notebook. Now to retrieve the data, you can just use the indices that we have. So here we are using explicit indice that we declared, that is A. So we'll be using that to retrieve the value 10. As you can see, A has a value 10. And we are using it from SER. So we are using it from here, right? Which we use dictionaries to make. Now, this is a small exercise for you, and you can go ahead and solve it. All of these notebooks, once again, will be available on the GitHub. So you can, the links are also shared in the chat. So you can just go and check it out from there. And make sure you go through these notebooks, because at the end of this whole session, you have a task to do. So make sure you just walk through all of this and understand everything well. Now you can also add two series together. So what we have done is we have created a series SER1 and SER2. Both of these are series with indexes and values for the respective indices, and I'll just run this. And now, yeah, here's one thing that we need to know. Okay, so we have A2, B4, C nan, D8, and E nan. Now we did not mention any nan values over here, but we still have nan after adding two series. So just understand this basic rule that if you add anything to nan, it automatically converts the whole thing into a nan, right? So nan is basically not a number. So what is happening is, if you look closely, in SER1 we have ABCD, and in SER2 we have ABED. So there is no C in SER2 and there is no E in SER1. So by default, when we are adding these two, the value of E is getting added to some NaN value, and similarly the value of C is getting added to some NaN value. So both of these result into a nan value, and this is what we get as a result. So when it comes to series, this is all that we have. So just quick recap. It is a one-dimensional labeled. It is a one-dimensional labeled array that is capable of storing any type of data value that you provide to it, provided that all of these data values are the same types. Moving on to data frames. So data frame is a two-dimensional structure that stores the data in tabular format, which can be changed and edited as per a user's requirement. The closest thing that I can link a data frame to is your Excel sheets. You have rows, columns, and it looks like a table. So you will see what I'm talking about in just a second. So this is the command that we use to create the data frame. In this case, we are not using any data set in general, but we are just creating our own data frame over here using some random values. We'll come to the data set part once we are done with this notebook. The next part teaches you how to use all of these things that we just learned with a real world data set. So we are using numpy.random to import random that we just saw, that Aman just gave us a great explanation on. And yeah, so we are using this. We are creating a 4x4 matrix using ABCD as our rows and WXYZ as our columns. And these are just random values present in our data, which were created using random. Okay, all right. So next thing is that we will be just grabbing few values from our data frame, and I'll show you how we do this. So we are just printing the values for W. So W is our column over here, and ABCD are the rows. So corresponding to these, this whole column, we are getting values for each row in this format over here. Similarly, we can grab more than one row using the same format. So we are, in this case, we are, sorry, columns. So in this case, we are grabbing columns. In this way, we are grabbing W and X as well. Now, this is a small exercise for you and that you need to complete. And once again, it will be available in the notebook on GitHub. Yeah, so this is how you create a new columns or make columns from pre-existing ones. So I'll just run this cell for you. So as you can see, we are adding a column new to our existing data frame, that is DF, and we are using X and Y to do so. So what we are doing is we are adding the values of X and Y in order to create this new. Now df.head, what it does is it gives you the top 5 rows present in your data set, right? So in this case, we are creating a column like this. There are many ways to create a column. I'll just show you another way that you can use to create a column. So I'll create a list over here of 1, 2, 3, and 4, and I'll be using this to create a new column. So this is how you create a new column. Sorry. And if I have to show you the new table now that we have. Yep. So as you can see, we have new, which we added using X and Y, which you created using X and Y. And we have new one, which you just created using a list. So there are many ways to create a column. You can obviously go through the documents for Pandas, which is very well written. And you can also come up with the ways in which you can add a new column to it. So for now, this is how we added a new column. And many times what will happen is that in your data, you will have some columns or features that you don't want while making a model. So what you will do is you will just drop them. Maybe it can happen that a column which is not important and it has some nan values, and you think that it won't impact a model in any way. So you can drop it by using df.drop over here. So in this case, we are dropping new, which is a column that we created. But what if we want to drop multiple columns? So let's drop new one as well in this. So this is the code that you will run when you just want to drop one single column. I'll come to what are these things in just a bit. So we are dropping new as well as new one over here. So we are dropping two columns that we just created, the new and new one, and we are giving access equal to 1, which means we are choosing columns to drop and in place equal to true. Now, what happens if you don't give in place equal to true? So in place ensures that these columns are permanently deleted from your data frame and do not show up next time when you are calling your df or data frame. So if you do not give this in place equal to true, it will be temporary drop and the effect won't be permanent. So we are just permanently dropping the columns, and make sure you don't run this again and again, because it will give you an error, because these columns won't exist in your data frame once these are deleted. Now we'll just call head on this, and hopefully we don't have those columns. And as you can see, we don't have new and new one anymore. So this is what we have. Now you have an exercise for waiting for you that you can solve later on. Now we'll come to in the start, I talked about indexing, implicit and explicit. Now we'll be taking a look at a better way of grabbing values from your data frame. Now you can obviously use slicing and fancy indexing in order to retrieve the values from your data, but it is better to use LOC and ILOC, which are the methods to grab your data from the data frame. And I'll just explain you what they do and how they work. So here I have written helps in fetching the row by using the row name, that is for LOC. So what LOC does is that it's basically grabbing the values from your data frame using the labels that we provide them. So it won't use the index values, it will use the column names or row names to grab the value from your data frame. So when I run this df.locc, so we are getting the row C from here, and these are the values for corresponding columns that we have. So this is what is getting printed over here. Similarly, when we use ILOC, what it does is ILOC gives you value based on the indices that we have basically. Similarly, as you can see, the values are same, because when we go in our data frame, you will see 0, 1, 2. So for 2 we have C as well. So indexing starts from 0. So this is what we get as a value. Now I'll get a column for you, and this is for you to guess in the chat right now. Just by looking at this and this, just tell me what will be the type, like what these single brackets and these double brackets represent, just for your fun activity in the chat right now. So just go ahead and type it out. And so this is how you grab a column from your data frame. And if you want some specific value, which is some like a particular row and a particular column, so you can give the rows and the columns that you need, and you will get the value that you want. Similarly, we can get multiple values from our data for multiple rows and multiple columns. Now this is what you will be solving after this whole session. This is then exercise for you. Now working with missing data. So most of the times your data set that you have will have a lot of missing data in it. So a lot of nan values to deal with. So Pandas has has many features actually in order to deal with these values. So what we are doing is we'll just run this. So we are just using this dictionary to create our data frame, and these are the these are the columns that we have, A, B, and C, and these are the values for each. So as you can see, we have some nan values over here present in our data in A and B column. So there is one method which will help you in dropping all of these columns, all of these rows that contain nan values. So that is df1.drop_na. So that what it does is basically drops all the nan values from your table. So I'll just run this, and as you can see, the only output that we are left with is the first row, because the first row does not contain any nan values, whereas the second and third do have nan values. That is nan, and you can also fill these values with any number that you want or anything that you wish to fill in them with. So as you can see, I used .fillNA and gave a value of 0 to fill these nan values that we had in our data. So what it's doing is everywhere that it detects there is a nan value, it just replaces it with 0. That's all it does. And just to conclude this notebook, we have another exercise for you, which will help you practice all of these concepts. So just to recap all of this that we just learned, we learned about Pandas series, Pandas data frame, how we can grab elements from a data frame, how we can make new columns in a data frame, and how we can add new data present to our data frame. We used arrays, lists, and dictionaries to create our data frame and series. And then to just sum it all up, we used a data frame which had missing values and learned how to deal with these missing values overall. So next up, Indrashish has some real world example of how we use Pandas. We'll also introduce some new concepts in those notebooks, in that notebook, and Indrashish will walk you through all of it. So Indrashish, I would like you to continue with this.
That was a great session on Pandas, and now that we have got the primary functionalities of Pandas and how to work with data, let's get on with the real world data set. So is my Colab visible?
Yeah.
Okay, so the first thing about data analysis and manipulation on a dataset using Pandas is that we need a CSV file, we need a dataset. So as I already told you before, we can always use CSV file, TSV files, text, HTML docs, and even SQL databases. So as of today, we'll use just a comma separated value file, and again we'll import the dependencies, and we'll keep this for you to explore. Now, reading a file, before reading a file in Colab, we'll need to upload it, and this is how you do it. So I have the data file here in data. So I upload the Titanic file in Colab. Now this is a temporary version. This won't be available throughout this session, or like it will be removed after a certain period of inactivity. So now this Titanic is loaded into your notebook, and we mentioned the path here. So we can directly remove the content portion too and use simply titanic.csv. And since this is present in the content section, so even using content is fine. So we'll pass this path to a pandas function called read csv. What read csv does is it takes the data set we have in case of read csv, it takes a csv file and converts it into pandas data frame that we learned about just now. So I'll just run this cell and I'll print the data frame that it provides us. So this is the data frame we got from our data set. So we have passenger ID, survived 0 or 1, and 0 means it didn't survive, 1 means has survived. P class, the class of the passenger, the name of the passengers, the sex, age, the siblings or spouses, number of siblings and spouses, the parchment, ticket, fare, cabin, and embarkment. So we have all this data in our data frame, and this is how we load a CSV file into our notebook. Now again, we have a exercise here, and you guys can do it later on. So after loading our CSV file to a data frame, first thing we'll do is data analysis. Now, in case of data analysis, we don't cover each and every topic here. We'll be covering it extensively during the upcoming sessions. And let's just get a brief data analysis using Pandas. So the first thing is a total overview of what our data looks like. So we have a function called info. So what does info do is it it provides a detailed log of the name of the columns, the non-null count, the data type, and the memory usage of our data frame. So as we can see here, there are a total of 891 values or samples in our data set or data frame. And there are some columns which has missing values, like age has missing value, cabin has a lot of it, embarked has only 2 of them. And we can also see the data type here, though most of them are like integer, some are object, and some of them are float. Okay, so let's start analyzing our data to try to gain some insights on it. The first thing is the passenger survival count. So to count the number of data present in our data frame, we have a function called value counts. It takes input a label or a name of a column or a list of all the some columns together, and it prints out the count of each of the numbers or categories present in our data. So in case of survived, in case of the column survived, the zeros, the number of zeros are 549 and the number of ones are 342, which denotes that there are 549 deceased passengers while 342 survived passengers on board. Next, we're going to see some distribution of the passengers with respect to some specific columns. And for this, we're going to use 2 functions called group by and pivot table. Now, what group by does is it, as the name suggests, it groups your input data by series or by columns as per your requirement. And pivot table is actually a more general type of function which creates a spreadsheet style pivot table. And just like the data frame we saw, it creates a spreadsheet style pivot table for you, and it can be used for the same purpose as group by, but it has a lot more functionalities too. So we'll just start with the group by function. Now, how does group by work? Inside the function, as a parameter, we provided the list of columns we want we want to group them. And this here, the name is that after grouping the columns, after grouping them, we're extracting only the name feature from our grouped data set, and then we are using count function to count the number of names present in each of 6 and embarked. So let's run this and we'll find this thing that we have 6 and we have embarked. Within 6 we have female and male, and within embarked we have 3 categories, C, Q, and S. I'm sure you'll get the details of the data set or the data present in the data set in the link provided. For now, let's just understand that embarked has 3 categories of data, C, Q, and S, and 6 has female and male. And out of those, we see that in case of female, the passengers embarked from C are 73. There are 36 passengers embarked from Q who are female, and 203 passengers who are female embarked from A. So these are all one and the same thing, and this is just how you represent or like try to gain insight from the data. Second is we can also use a pivot table for the same thing, and in this case we'll first provide the value on regards to which we want to print our data, and we'll provide the index as sex and the columns as P class or passenger class. So this is a single level pivot table, and we'll see the output. So as I told before, it gives a data frame like a spreadsheet style pivot table to us, and this is just how a data frame is represented. So as we have pointed out, index, we have provided index as sex. So the index are the categories of sex present, and in case of columns, we gave the categories of passenger class. So in passenger class contains 1, 2, and 3 labels. So our column count is also 3, and these values you see here is the survived percentage, because survived has 0 and 1 value. It shows the 1 value here, and actually it tells us about the how many people in regards to their sex and passenger class were able to survive. This is what this single level pivot table denotes. We also have a multi-level pivot table, and for that we use another function of Pandas called cut. Now what cut does is it actually bins the data provided to it into the required bins. So since we provided it 3 values, what it will understand is that I have been given 0, 18, and 80, and I'll need to bin the date, the age column according to these values. So there will be 2 bins created since there are only 3 values given. So the bins will be from 0 to 18 and 18 to 80. Okay, so this is how we like cut or segment the data set provided to it, and we store it in the age variable. So age, now we again use this age, we pass it on to our pivot table. Again here we have our values as survived. We give the indexes as sex and the age we just cut from our data set, and then again the columns will be the passenger class. So what this will give us is just like the one we had in group by, we had 2 indexes. So in our case will be sex and age, and in case of age there will be 2 bins, 0 to 18, 18 to 80, and according to these bins the data will be divided in 3 different columns of passenger class 1, 2, and 3. So this actually tells us about the people, their gender, and their age group from respective passenger classes that were able to survive. So this was all about data analysis. I'm sure we'll cover a lot more in a lot using all of different types of visualizations in the upcoming session. So let's get on with the data manipulating or data wrangling part, also called pre-processing. So as we have seen in our data set, there are different kinds of data, right? We have numerical input, we have object or string type input, we have categorical input which are present in string format, and also categorical input present in numerical format. So if you pass this data to a machine learning model, it won't be able to interpret it, and in order to make it interpretable, we'll need to actually convert all this, and we also need to drop the null values present and make it a form, a matrix of data which can be passed on to a machine learning model. So that is what is done by data pre-processing. So in pre-processing, the first thing we'll do is resolving missing values, and to check the amount of missing values in each column, we use the isNull function along with sum. So what does isNull function do is that it detects the missing values in throughout the data set. It detects the missing values throughout the data sets and labels them as true and false. And we use the sum function to sum up all the true values, or we can say the false values in each column. So let's see how this actually looks. Okay, so here you see that we've already previously seen the amount of non-null values present in our data set, and this just provides us the number of null values. So we already saw that age contained 177 null values, cabin contained a large amount of null values, and we got the exact number 687. So this is how to check for null values. Now we can clearly see that cabin, according to the data frame, K-bin contains the number of K-bin. Is it actually important for a machine learning model? Well, it doesn't seem so, right? So, and also it contains a huge number of missing like non NaN values. So, I guess we should drop it, right? We have already seen how to work with drop, but let's again do it. We'll take the k-bin column from our data frame. We'll use axis equals 1 denoting the columns and in place equals true. Now what this does is it drops the k-bin column from our data frame directly. Other than dropping k-bin column, we also have null values in age and embark, but age and embark seems pretty important, right? So let's not drop the column totally, and let's just remove only the rows containing these null values. So how to do that? We do that using the drop na function. What this drop na functions do is that it removes missing values from our data, and by default it takes x is equals 0, so it will remove only the rows contain all the rows containing null values. So after we remove the null values, we can see that there are no null values in like age is clean and clear. There is no k-bin column here, and also it has reduced to 712 rows and 11 columns, which was previously 891 rows and 12 columns. So here you see the change in our data frame, and this is after dropping the null values. Here I've again given an exercise where you need to fill up. We have already seen the fill na function and try it out here in your exercise section. So now the next section is extracting required features. We have already seen different kinds of features, right? Like name or the cabin number, or the embarkment. They are we can also say the ticket number. They are not actually important in case of machine learning models. So we need to extract only the important features from our data set, right? So we do that using the various functions mentioned by Ayush previously. We can use LOC, ILOC, or we can just directly use double braces here or third brackets here to directly extract the columns by their labels. So you can do it in any process you want. This is just what I have shown here. So we stored the collected or extracted features in a variable called features, in an object called features, and as you can see here, we have age, embarked, fare, parchment, passenger class, sex, and siblings or spouse. And again, the number of columns is reduced to 7 from initially 11. So this is how you do it. As I've seen here, you need to do the same thing as well in case of target column. So these are our features, right? These are our features, and our target, the one we have to predict, is the survived column. So using all these features, we need to predict if the passenger has survived or not. So survived will be separate from all the feature variables, right? So we what I did is use the different object to store the survived column. But as I've shown here, you'll need to do this on your own. I'll just run it here, and the output will be something like this. We have 0 to 890, and there are 712 objects. And as you can see here, 0, 1, 0, 1, this is our survived column. Now that the data set is segregated into features and target column, what we'll do is converting the categorical features to numerical ones. There are various methods available, but let's use a method that is not generally used nowadays. That is using a dictionary, using a Python dictionary. So in this case, since there are categorical variables in the embarked, as well as in our feature data set, there is embarked and sex. So we need to convert embarked and sex into numerical data. And the way I do it is using a dictionary. I use a dictionary within a dictionary and mention that in case of embarked, we need to change S into 0, C into 1, and Q into 2. So this is how I label the categorical data into numerical. And we also have sex here. We convert the sex from as female equals 0 and male equals 1. So this is how we convert our categorical data into numerical one. And the conversion is actually not done here. This is how we define it. Now we will use the replace function of a data frame. So features is a data frame, and we have a replace function where we can give the dictionary as an input, and we'll always type out in place equals true for like a permanent change. And what we do here is in a data frame, in case of embark, we, as I told before, we replace all S, C, and Q with 0, 1, and 2, and female with 0, male with 1. So that's how the replace function works. This is another one. Okay, sorry. Yeah, here you go. See, in place of embark, we have 0, 1, 2 here, and in case of 6, there is 1, 0, 1, 0. So this is how you convert a categorical variable into a numerical one. There are various other methods present, and we'll discuss it in the upcoming sessions. Don't worry about it. Now, that was it about data manipulation. But you might want to actually extract these data sets into your CSV files back again. So we created a fully furnished features data frame. We created a fully furnished target data frame. Now, using the to CSV function, we can convert our data frames back into CSV files again. Now I'll just run these files. We also used index equals false. So what happens is that the indexing present here is also detected by to CSV function, and it gets into our CSV file as another column, which often troubles people out. So we can use this parameter called index equals false, so that the index of our from our data frame will be ignored and only the features will be stored in the CSV file. Now, if we refresh it, we'll see the target and features CSV files here. Now, if you open the features CSV file, we can see just like we had our features data frame, we have a CSV file with it, and same with target. So we have a single column survived and with 0, 1, 0, 1. So that was it about pandas and working on a data frame. Obviously, this is not the end of working on a data frame, and this was just a basic one. We'll obviously know more about it in the upcoming session. So I'll hand it over to Aman to conclude the session.
Okay, so to complete this session, we are going to move on to our final quiz of this session. I'm dropping the link in the chat now. You guys can go and attempt it. Remember, there will be only a 2-minute time limit to attempt this quiz, and the first ones to give the correct answers will be getting a cool swag from DSC. So the link has been dropped now. You can go ahead and attempt the quiz. Best of luck to all the participants.
Best of luck, guys.
The responses have started to pour in. You guys need to be quick if you want to win. Also, make sure that once you have completed the quiz, share the screenshot of your scores on Instagram while tagging DSC VIT Bhopal. We'll be drawing a lucky winner out of those who share the responses, and they'll be getting some awesome swag.
Also, I would just like to add one more thing to all of this. What we discussed today, we have been discussing this in the ML Book Club on our Discord channel, the DSC's official Discord channel, for quite some time now, where we conduct live sessions and we come together and discuss stuff from a book that we are reading, that is Python for Data Science and Machine Learning. So make sure you join our Discord channel as well, because there is a lot going on over there, and you might find some really great resources that would help you out. So make sure you do that too, because the links have already been dropped in the chat, so just join it and come be part of the ML Book Club.
Also, one more thing that I'd like to add. After the session is over, you need to complete all the exercises that were given in the notebooks. And if you find some difficulties with those exercises, you can ping the DSC ML Club members in the Discord server, and we'll help you out with your doubts. So make sure you submit those notebooks before midnight today. Okay, so the time for the quiz is up now. I've got a lot of responses from you guys, and we'll be selecting and announcing the winners after this session soon enough. So with this, we come to an end of today's session. There will be more workshops in the future where we'll be working on exploratory data analysis as well as your first machine learning projects. So stay tuned with DSC ML Talks, and this is going to be very fun. And you can always ping us on the Discord server if you need any help regarding any doubts with machine learning or anything at all. So with this, we end the session now.
So if you have any doubts, go ahead and join the Discord server, ping us, and I think we had great fun in sharing all of this with you and doing this whole session, and I hope you guys enjoyed too. So yeah, that's pretty much it, I think, Aman.
Have a great day then. Bye.
All right, bye bye.
That's
See you
it, I
guys.
guess. Goodbye.
Bye bye everyone.